We start like this. We do this and we show off
we
the
pop our
luck
collars
is
a
not a
little bit.
strategy shirt.
I got it.
That's right.
I got it.
We're rolling. All right. Well, I'm keeping that in, by the way.
I like it.
Yeah,
I'm not saying to cut
exactly.
it out.
All
I like
right.
it.
Well, you probably realize we're silly. We're seriously silly.
Yeah,
Silly,
well,
silly.
I mean, I think
No,
we're
no messing
like-minded that
around
way.
there.
Yeah.
No messing around there. Emily,
Hello.
so good to see you
Yeah,
again.
good to see you too.
It's been a couple days already.
I know.
A lot's happened, I'm
somehow.
sure.
I know, it has. It really has.
You've been rolling, I won't say rolling the streets. You've been rolling the hallways.
Yes. Well, there's been a lot of feet on the street. I think
Yes.
if I were to count my steps, it would be quite a lot.
Okay.
We've been hustling around the Moscone Center mostly. Is it Moscone?
It is
that right?
Moscone, yeah. We'll go with that.
Yeah. Thank you. Appreciate it. Yeah, make me feel very comfortable. But we had a lot of meetings, a lot of great conversations. So it's been really good.
That's good.
Yeah.
That's good. And we're going to get into what some of those conversations were about.
Awesome.
Let's take a look back at Kubernetes.
Yeah.
And kind of the world of containers. I mean, I think shifting left and finding new ways to build software and deliver software and maintain software and then make it portable, right?
Mm-hmm.
Obviously, a lot of those things were enabled by Kubernetes.
Yep.
Tell us a little bit about that and maybe some of the challenges that the original design of that and implementations of that have kind of left us maybe in a spot where
there's some open
we
questions.
might not want to keep in place moving forward.
Yeah, I think there's a lot of good energy and love for Kubernetes even still. I think 10 years later, I think it was 10-year anniversary or birthday of Kubernetes just a couple months ago, and I think it's done a lot for the community. One of our angel investors is Joe Beta, and he's one of the creators of Kubernetes. And one of the things we talked about really early on in Edera's journey was kind of the Kubernetes was really not created for multi-tenancy. Like the way in which it was kind of expanded and used, it was really not supposed to be as, I would say, distributed in that way. And what I think has started to happen is because it solved so many, like you said, like portability and flexibility, and there were so many advantages to it, the security element inadvertently became an afterthought. I don't think it was deliberate, but I think that there wasn't, again, because it depends on how you hold it.
Right.
And people were holding it different than it was initially intended. And so a lot of different security risks started to come in. And when you're dealing with containers, I think we talked about this the other day, is it's just a set of processes and it's not an actual thing. A container isn't real. And even when you're running, Kubernetes containers and Kubernetes is somewhat synonymous in this example, you didn't really expect there to be so much risk. And I would say over the last probably 18 months or so, there's been a lot more of a understanding and a shift to understanding how risky that is.
Right.
And I can also appreciate that the flexibility, pace, portability of containers has changed the way we develop. I mean, it has made things a lot faster, more agile, and I don't think we want to give that up. But we did give up some of the advantages of virtual machines with some security hypervisors and a lot of things we might dive into a little bit more later. But it's been an evolution, and I think now we're at a place where we can't really look away. It's kind of like once you see something, you can't unsee it.
Right.
I think that's where we are now, as the evolution of how we're using it was different than its initial intent.
Can you give me an example or two of, I think, well-known deployments or organizations that have used it a certain way that worked, but leave us in this position?
I mean, most enterprises, I think it's like 96%, it's like a Gartner stat, use Kubernetes in enterprises. So most people are using it in a way that they would say fundamentally, using air quotes, work for development.
Is
what
that the
you're
focus?
doing,
Is
but
really
it's
for the
focusing-
engineers to deliver, right?
Exactly. Like engineers saw it as a kind of a liberation at the time, and they brought that in. But I think it's now security teams and engineers, to be fair, when they started really becoming aware of and having to manage some of the security components. Like a lot of engineering teams now are dealing with even compliance, like having to deal with FIPS or FedRAMP. Like it's actually getting pushed into the engineering team's responsibility to be able to report back, how are we securing our containers? That's the type of stuff I think
and if you look at FedRAMP or FIPS, is not just the thing, it's a process as well.
Exactly. So I think a lot of enterprises have done it well for development. I think it's created a lot faster, more meaningful pace. The problem now lies is that anybody who is trying to use multi-tenancy is sitting there realizing I can't really do that safely. There's
Describe the multi-tenancy thing.
like so multi-tenancy can mean, I mean, some people use it in different ways. The way I'm using it is like I'm running workloads next to each other. That can be if I have multiple customers, I might be running them next to each other, and I have a shared kernel between those containers. And that can be also just within your own ecosystem, you're running containers or different departments, things alongside each other. So multi-tenancy means you're sharing a kernel with multiple workloads.
Right.
And
the risk there is cross-tenant.
Yes, like issues. So again, going back to the idea of that a container isn't an actual thing that is containing a thing. It's just processes next to each other. If I am able to get into a container vulnerability exploit, I can actually pop into, or lateral movement is what they say, like go into other containers. And that is very scary because you can try to mitigate that with less vulnerabilities and other things you can do, but 0 days are well known to be, we find out that you can exploit something and we aren't able to patch it yet, it wasn't known. And that's when you think something might be safe because it's in a different, again, container. But if it's sitting next to one and sharing a shared kernel, you're putting the same risk.
And I guess it's scary enough, just forget the tenancy part. It's scary enough if you have multiple instances and the lateral between, I don't know, a customer's chatbot instance over to the financial
proprietary PII data, something,
exactly.
The keys of the kingdom.
So that's bad.
Frightening.
But when you start talking about, I don't know, let's say a managed service that has multiple clients, and you pop a retail shop that then
and then you get into somebody else's.
Not cool.
And what a lot of people have been doing to try to mitigate this is they'll do single tenancy, which again, you're running different environments. And we've been talking to customers who are doing that, and it does eliminate that problem, but it is ridiculously expensive to do. And so it's not manageable. You can't scale.
I've probably experienced
orders of magnitude. Particularly if you are a large enterprise. Maybe if I'm a smaller business and I have to run 10 different single tenant environments, it's still obnoxiously expensive.
Does it impact management as well?
You're having to manage different environments. It's like you're spreading it's time and money. And again, it doesn't scale over time at all. So some people are trying to do things that are hedging their bets in certain areas, but in order to actually have isolation in current stage, obviously we go into Edera, it's a little bit different what we've built, but the only way to mitigate that was to do single tenant environments, and it's cost prohibitive for most.
Well, let's talk about what you built. I don't want to delay that, and we'll talk about what it is, how it works, why it matters, the outcomes of that, and then we're going to look at the future, which is now. After that, and I'll hold that for a moment. So, just describe what you've done, how it addresses what we just talked about, and maybe even more, just as a general picture, and then we'll dive into some of the fun stuff.
I'll take a quick step back and kind of the why, and then what ended up happening and what we actually use it for, because I think context is important. We founded about a year ago, in April 2024. My co-founders, Alex and Ariadne, are both incredible technologists. Ariadne was behind the Chain-Guarded Images product. She built Wolfie, it became launched. So she's very, very deep in the container ecosystem, Linux distributions, those types of things. And Alex grew up at the age of 11. She started programming. She took her first programming job at 14. She's incredible. But she's been working the last 6 years before Edera on edge devices, like working for Google on the edge devices. And what's I think really unique about understanding the edge is it's complex. You're dealing with different hardware, different software, complexities. You have to be able to run containers, but you can't necessarily have hardware or like virtualization extensions. There's a lot of limitations. It has to be really efficient. And so when Alex was looking at the issues at the edge specifically, it was looking at how do I run containers efficiently without the need for access to hardware. Is that possible? Can I get the security guarantees and isolation? And so she went out on this adventure to try to figure it out. And in doing so, she was looking at a lot of different tools. And I think it's really important when we're looking at solving something really complex like container security, being that it's so prevalent, that you're actually looking at history so we don't repeat the same mistakes in other technology that we did before, and also to look at what did work in certain different technical elements and then see if there are ways to apply and modernize that. And when Alex went into a project called Zen, which is a
Hmm.
hypervisor for VMs, it's about 20 years old. What she realized is there was a lot of benefits there. It wasn't container native yet, which is what we did end up doing. But she looked at it and said, oh, look, there's something called para-virtualization, which means that I can actually not have to get virtualization extensions to be able to get isolation. I can do a lot more. I could be more portable. It's smaller. So she took that, rewrote it in Rust for memory safety and performance guarantees, and then made it container native. And originally, she was looking to solve situations at the edge or compute security stuff at the edge. And then Ariadne took a look at it and was like, I think you might have just solved for container security. This is pretty darn big. And fast forward, Ariadne left to go start the company with her. I called her and said, hey, do you need someone like me? I could be really helpful. And then this was born. And the reason why that context is important is because what Edera does is really low level. I mean, we are essentially a hypervisor that sits below the kernel, and we help manage, we essentially change the way containers are run. And the reason why that's important is, like, if you look at containers not being a thing, we actually put containers in what we call a zone, and we are able to isolate them from each other. So in fact, it essentially makes a container contain just by running them differently. So finally you get the promise of what we originally thought containers were at the time, containing as its name, but it wasn't, and then makes that actually possible. And I think that
Live up to its name finally.
Exactly. Somebody needed help renaming those. But what's really cool about that is it gives the advantages of VMs, like virtual machines, in the container world. So I want to be able to have a hypervisor that actually, isolates, but I want performance guarantees and flexibility of containers. I want to have memory ballooning capabilities like VMs where I don't have to over provision containers. I can do that now here.
Yeah,
it brings the primitives over, which we didn't have. We kind of split. We chose portability and flexibility over security, and in many ways, like CPU memory management. And we're kind of bringing that over by actually using some older technology, reimagining it, and putting, the reimagining word is so silly, you hear it a lot with companies, but it really was. It's taking an older technology and making it and innovating it. And I think that's what makes it really unique.
I'm picturing a fork and the
exactly
security stuff got left behind.
Yes, exactly. Which is meaningful because you get the confidence of knowing that something's tried and true for 20 years at its core, but getting rid of a lot of the technical debt, making it efficient, making it memory safe, and being able to utilize it in, the actual environments today that people are using, which are containers.
So, as an engineer building stuff, and maybe I need to step back myself so I'm understanding it properly. Who is taking Edera and putting it where?
Yes, that's a good question. As a developer, you don't see it at all. It's transparent. You develop just like you always have. You use whatever containers you want. You don't want to disrupt that.
They know what they're doing.
They're doing what they're doing, and people have their own flow, and you don't want to disrupt the flow. You also, even when you have something really important and innovative, if you have to retrain people and take them out of their typical path, it's a non-starter, and understandably so. Like it's hard to get your flow, but it's actually really the platform infrastructure, SRE teams, like people who are like managing more so the infrastructure itself. They go by a lot of names.
So
sometimes it's
the code's delivered to them.
Yes, and then they manage the infrastructure.
Got it.
But where we run is at the infrastructure. We technically plug in at the CRI, the container runtime interface level. And when you run us, it sits below the kernel. But developers are developing as they always would. But what it does is, again, transparent to them, their containers are actually isolated and moving around. And transparent to them, well, because the infrastructure teams, they're responsible usually for uptime. They're like the 3.9 crew. And this is giving them a lot more flexibility in how they can maintain cost effectively, because usually they're also the ones that are managing the AWS or Azure or GKE bill. And so this is kind of one of those like infrastructure teams' dream, because they don't have to change the way they work. They don't have to tell the developers to change the way they work, and they get the advantages of better and more agile infrastructure, more efficient infrastructure, and secure infrastructure at the same time. So it's really easy. It's just a couple lines of YAML to get it going, which again was a huge priority for us. Is if we knew we wanted to change the landscape of computing, we knew we had to do it in a way that was frictionless. Because anytime you have to, again, we could do a lot of things secure by design, but it means we have to start over.
Right.
And that's just a non-starter for most everyone.
So, I'm trying to visualize. I can see under the hypervisor.
Yes, yes,
Um, what's I guess so portability remains,
yes.
bursting, flexibility, all that
hmm
stuff remains. What about the cost? Is there any difference in that in terms
Yeah,
of
so that's a big question we get is
Mm,
performance impact.
right?
What's the performance impact? Because I think hypervisors and the VM sense, or even some of the other tools who have tried to do
Mm,
isolation before, tools like gvisor
mhm,
and Kata, there's restrictions on either where you run it. So, do I need bare metal access or not?
right.
Can I do stuff in the public cloud? And the answer is no for a lot of them. Or is there a performance hit? Like gvisor, they try to do like a kernel emulation kind of thing, and it ends up being a 30 to 40% performance hit. The advantage of isolation is there; the practical
Right.
usability of it is
Yeah, 'cause
not.
I'm picturing a shim, and a shim can be
Yeah, like
a,
lots of
a, a,
things.
sli- a slice
Yes.
or a
Yes.
big fat block.
Yeah. And we actually have our head of Edera research, Marina Moore, did an academic paper on our technology and compared it to gvisor, just like plain Docker,
hmm
Kata, to be able to kind of show what our performance metrics are relative to running our software, because we knew how important it was for people to be able to see objectively that they're not going to see any sort of large performance degradation. And we are across the board generally on par with a typical Docker container. In some cases, we're actually more efficient because of how we schedule CPU
Mm,
and memory, but it's actually very cool in that way, which gives us a lot of hope, I think, in the
mm,
world that we can actually solve for this problem, because we know that businesses are going to have to deliver results first.
right.
And security, though top of mind, ends up being second to that.
Mm,
Um, and being able to not have those be a trade-off, like in real, like
right.
real terms. You see that in marketing jargon, but that's a true term here. Is like if you don't have to
Mm.
trade that off, then you can have both at the same time.
So talk to me about. So I was initially picturing a shim or a layer,
hmm
but you actually describe a container. So I was
hmm
starting to visualize walls, but it's
hmm
completely enclosed.
Yes, in a
And
zone. We call them a zone.
zone. There we go.
hmm
That does two things in my mind. One, outside penetration in, and inside leaking out.
Out. hmm
So, what are some scenarios that traditional container implementations experience, or
Yeah.
weaknesses to, or vulnerable to,
Yes.
that you address specifically?
Yeah. So the zone is really more like the out, like inside out. So like if
Okay.
there's a vulnerability that exists out in the wild, you can still access it.
Okay.
So
So
you
you're
can
not
still get.
shielding.
We're not shielding on the in. What it
Okay.
does is that when you get into the container,
Got it.
you cannot pop out.
Got it.
And that really is the big scary part
Yep.
of the world here.
Mm.
So there are, like, if you have a container that has, we'll say, keys to the kingdom, security
Mm.
keys,
Okay.
PIIs, social security
Mhm.
numbers, whatever it may be, you don't, like, if somebody gets in, that's really bad. And there's measures of other companies. ChainGuard is one of the places we spend. I think Minimus is another one that just launched, that do like small vulnerability kind of like images. And the kind of premise of that really is to try to limit the attack surfaces going in.
Got it.
The problem is that you can't mitigate 0 days and those types of things with that. But
Stuff
if you have, these minimal images side by side, let's say you have your security keys or something really precious sitting there, and it's, you got a 0 image, whatever, but you have a legacy application sitting next to it that has end of life software or something like that.
Mhm.
You can have a super great container sitting next to one that you made some questionable decisions, and or you have legacy needs within an enterprise, which is very typical.
Oh yeah.
I mean, and understandably, there's a
Tech
lot of
debt,
reasons.
it's a real thing.
But yeah,
Mm.
then it doesn't matter what one's sitting next to it, you can pop into the next one, and that becomes really scary.
Yeah.
And so for us, it's really about making sure that the context is there. So if you
Mhm.
can't eliminate that vulnerabilities will always be out in the wild, how do I protect myself when
Right.
and if something gets popped? So
Yeah.
for security professionals, when we talk to CISOs, they say constantly context. I just need
Mm.
context. I
Mm.
get these alerts. I know what's going on. Context. For us, it's like, if you know that your containers that have all the scary stuff are over here,
Mhm.
you want your scanning solution to yell at you when that happens. If you have stuff over here and it's not, there's nothing really in there, so you can pop. You don't have to worry about people trying to get. It's not usually that people get access
Use
to the
as
secret
a-
stuff
As a
first.
vector.
They use that as the vector to move. And so if you can trust your infrastructure and you know that nothing's going to
Mm.
move, then that 911 kind of red alert scenario is much less
Right.
prevalent, because you know which containers are the ones that are scary versus the ones that are not.
So is there a monitoring and alerting and of the container to say
Yeah.
we see some anomaly?
We have, I mean, our data
What's
is
going on?
exceptional that's coming out of it.
Mhm.
Mostly because we sit so low level. We have
Mhm.
a really detailed, I don't like using the word perfect, but my CTO
Mhm.
does, so I will say it because she does, and she knows a lot more than I do. But a perfect snapshot of what happens in your
Okay.
system. So, like, even if you do get it popped a
Mm.
container vulnerability, we can copy that and see exactly what happens. You can do really cool forensics with the stuff that we do.
Right.
We are not a scanning solution. We have eBPF enabled kernels, so we can work alongside some of the prevalent what we said observability
Okay.
solutions. But our data becomes the secret sauce. We have APIs for people to do stuff in Prometheus and other things, but for us, it's more about
Mm.
us being at the infrastructure layer, being your new infrastructure,
Right.
and then you can grab any other tools that are going to alert you. But those tools should be a lot less loud. We had one enterprise
Hope
tell
so.
us that they had 2 billion alerts a day. And you have those moments where you're like, I don't even know what that means. Like,
Mm.
conceptually, like, is it even worth having alerts? Like, what do you
Right.
do with that?
Right.
Like, what does that even mean?
Mm.
So for us, we hope to help that company that has 2 billion alerts contextualize that a lot more than, you know, they have today.
Any other stories like that where you're
Yeah, I mean,
helping companies?
that come to mind. I mean, a lot of what we hear is because there's no proactive security, because we're talking a lot about the security. There's obviously the
Mm.
infrastructure,
Yeah.
efficiency piece of this too. But being at a security conference, it
I know.
feels appropriate.
I'm drawn to
Yes, I know. It's very
the
cool.
performance and
I know. I
efficiency
love
stuff.
it. I know. I know. I love it. But what we hear is that because there's no real proactive security
Mm.
measures out there, most anybody who's marketing proactive, what they mean is we're trying to use AI to be as fast as we can
Mm.
when we see something abnormal occur to tell you that something's wrong. And then we can prevent other things from happening, meaning we'll tell you faster.
Right.
We are truly preventative. Like, it cannot go anywhere, in which case, like, that is incredibly important. So preventive. So what we've heard is people have layered like 6 different observability
Mm.
solutions on because they all kind of look at things a little
So they
differently.
couldn't find a
It's like
7.
it's like hedging their bets. Yeah, maybe there's more. We talked
If
to one
only there
enterprise.
was 7.
We literally talked to one enterprise that said we have every single container
Mm.
security solution. We just buy them all because like the risk is so high for us. So we see a lot of power in trusting your infrastructure. We're not saying don't have observability, but like, do you need 7? Like,
Right.
if you're hedging your bets because you need somebody to tell you as fast as possible, so I want all of them. We want that to not have to be the world we live in, which is why you end up with 2 billion alerts.
Yeah.
It's not from one singular observability platform. It's from
Right.
all of the ones you're trying to distill what's actually important,
Yeah.
and that
There may
becomes
be a lot of
unmanageable.
duplicate
Duplicate of, yeah.
alerts that are just from one root problem. That
Yes.
you eliminate the problem to
It's
begin
like,
with.
then you didn't have it in the first place.
I'm glad you're talking about that, and maybe I don't know if there's more to elaborate on it, but
Yeah.
the impact on AppSec teams and DevSecOps and a lot of the you're talking about observability, what's
Yeah.
going on, but there's still a lot of that in the build process too.
Mhm.
Is there any impact on how that looks and functions?
Yeah, like kind of the CI/CD
Mm.
kind of story. Well, I mean, we all I think know of like SolarWinds and kind of the fun that brought. Fun again, air quotes that brought. So there's a lot of risk in builds. You're bringing a lot of code in, and one of our case studies we will have coming out soon is on the efficiencies in CI/CD, but also security, because being able to build securely in CI/CD is really important, and people are seeing issues with that and have for a long time.
Right.
And, I won't be able to go as in detail as I know some of our team would, and kind of like Docker and those types of things in risk and build. But we definitely make that simple and more mitigated too, because if you're going to be bringing a bunch of code in, but everything that you're putting in can't pop out,
Right.
you have a much easier scenario of building without having to worry about what you're bringing into your containers, because it doesn't
Not that you
worry
shouldn't
about
do
where it's
that
going.
work, but it's a level of comfort.
Right. Yeah. Because I mean, there are going to be risks in build.
Yeah.
That is just inherent. So, and that becomes incredibly scary if you're
Mm.
looking at software supply chain security holistically. But that's where a lot of our power is too. Is that it's not production, of course. Like that's,
Right.
I mean, that's kind of your end jam. But like as you build, the more you can eliminate and have, more confidence there, the better.
So I know the answer, I think, already, and it's pretty cool. But there's been talk about vibe coding and,
Yeah.
and agentic AI and code agents writing code for themselves, which opens up all kinds of weird scenarios,
Yeah,
right?
it
And
does.
I go back to my QA days, quality assurance, where I actually did security testing as well. And I could fairly easily define the box that this thing that we built was supposed to operate in. And very few API stuff going around, but now everything's API driven, everything's open source, everything now writing its own code, polymorphic in a sense, right? I know the answer is doesn't matter if it can't pop out.
Yeah.
But what are your thoughts on that whole world and in relation to containers and what you're doing, kind of the future there?
I mean, vibe coding. So you're so current. We're gonna date ourselves with this episode over time, I think.
I know.
But it's so true. It's so big right now. So I'll be careful in my opinion here. I think there's a great case for it, and there's a lot of people that use it in a very responsible way. Product managers being able to like see and scope and those types of things. I know that when it comes
I've
to
heard lawyers using it, which is scary.
it's scary. It's a scary thing. And I just hope that people take the time to understand the implications of what that means. Even if you just look at it conceptually from like technical debt, like when you actually talk to people, I listened to a really interesting talk in London around KubeCon, I think it was Monkey Gross. We're talking about essentially vibe coding and AI and the risks. And one of the big things is like AI doesn't always make the simple decisions when it's coding, like when you would have a kind of a logical human brain who has like lived in the world. So the way in which you can actually troubleshoot issues when you're trying to come in is very difficult. So like you're setting yourself up, you start to use it in your core build, like you're setting yourself up for some pain. And that's not even, we're not even talking like security risk at that point. You're just talking about like legit, how do I use this in time and deal with my own technical
what the heck
debt?
did I write?
Yeah, what did I do? What did it do? How do I, because a lot about builds, like it's debugging.
Yeah.
I mean, a lot of our engineers are spending time like diving in complex rabbit holes, and when AI is going to make a decision, and in this talk in specific, they're talking and give examples of the decisions that were like highly complex in ways that it didn't need to be for a very simple solve, because it just took, what it found from its, whatever it was being trained on. That's problematic. And then you don't know what you're going to be introducing. You don't have the same kind of quality checks if you're just going to trust what it's bringing in, which you have people looking at it. But it does help. We do not hurt the process on the security side by existing and making sure that if something is malicious, it's brought in, that would be an issue in either build or production. But
Not a focus area, but you're not going to.
Yeah, I mean, there's a lot of opinions there, but we have a strong opinion on AI security. Like a lot of our product offering is focused right now on securing GPUs itself, because if you're building AI, you're using GPUs, in some cases TPUs, DPUs, but our technology is hardware agnostic, which is very powerful. But like we believe that people need to understand the risks of using and developing AI and using a GPU, memory wiping, knowing that you're not dealing with just a container, you're dealing with GPU itself and the risk of it staying in memory or on the GPU device. It's scary. And you've got AI developing and having memory management, wiping stuff, knowing and guaranteeing you can. And the complexities of that are wild. But if you have something like Edera where you have a hypervisor that sits again right above the hardware, and you can map everything that's happening, and you can confirm that the memory was wiped and you have data to back that up, that's powerful. Right now, it's not possible. So so building off of the vibe coding component of that, you have that and your vibe coding on that. I mean, I don't even sometimes I don't want to think about it because it scares me so much. But we're trying to do our part.
So flexible and capable. Who knows where it's going to take?
Exactly. You don't know. I mean, it's very powerful stuff. It's great, but yeah.
I'm getting the marker that we're done.
I think we talked too long.
My goodness.
Are we getting in trouble?
We're getting in trouble. But that's a good sign, in my opinion.
Yes.
And also a sign to say we're going to have more conversations.
I'm so excited.
We're going to do some webinars.
Yes. We're going to get deeper into the tag.
We're going to get into some of the stuff. We'll hopefully have some people online asking us questions that I'm not able to ask.
Yeah.
Because it's been a while since I've been an engineer.
And I probably wouldn't be able to answer. We're gonna
so
tap in Alex. We're gonna bring
the right people. The people doing the work. The people creating the offering.
Yes.
And it's gonna be super fun.
That'll be really fun.
Emily,
thank you so much for having me. I'm so grateful.
I love this.
Yes.
And your team.
Yes.
Amazing.
Thank you.
I said it the other night. I'll say it
again.
Yes. Super fun. Super smart.
Amazing. Thank you.
Very
Appreciate
caring. So,
it.
thanks everybody. We'll Stay tuned. Connect with the Edera team. Connect with Emily.